So we have four types of conic sections we're going to do. 12.1a, we did circles. 12.1b, we did ellipses. And today we're going to talk about hyperbolas. So you will notice that the equations are going to be very similar, but there's one little twist in it that makes it turn into a hyperbola. The graphs of hyperbolas end up kind of looking in a way as if we have two opposite facing parabolas. Sometimes they are going to be opening up to the left and the right. Sometimes they are going to be opening up and down. We will be discovering what you have to look for in order for that to happen. So what you want to copy down are these things right here, okay? If our x squared comes first, followed by our y squared that has to be a subtraction, then we get two hyperbolas that go to the left and to the right. If our y squared comes first and our x squared is negative, our hyperbola will open up and down. So the main thing you want to take away here is that our center is at 0, 0. This one opens left and right. This one opens up and down. So if our x squared is the positive and our y squared is negative, it's going to open up to the left and to the right. If our y squared is positive, but our x squared is subtracting, it is going to open up and down. So that's the main thing. Now let's think about circles and ellipses. If the circles and ellipses said x squared, y squared, that means they were centered at 0, 0. That does not change. That still stays the same way for our hyperbola. So if you just see an x squared and a y squared, that's why we're centered at 0, 0. So that doesn't change, okay? Only thing you had to fill out was the stuff at the top? Is that correct? So let's look at an example. Now, the examples and the homework. There are 5 things that I want you to do every time for each one of our homework problems. The first thing that we want to do, well, besides me writing it down a little bigger, the first thing we want to do is to identify how it is opening. This particular one has the y squared being our positive value. So that tells us that it is opening up and down. If the x squared came first and it was positive and our y squared was negative, it would go left and right. But the y squared being positive tells us that it's opening up and down. Second thing I always want you to find for me is the center. The center, just like always, is going to be an HK. It is found almost identically to where we find our HK for a circle and an ellipse. If it's by the X, it's our H. If it's by the Y, it's our K. So we have nothing by the X and nothing by the Y. We have subtracted or nothing from them. And so because of that, our center is at 0, 0. So if you just see a plain old x squared or a plain old y squared, that puts our center at 0, 0. Third thing I always want you to find is the slopes of the asymptotes. There are 2 asymptotes to these graphs. We have to find not only what it goes through the center, but we do need to find a slope to create that line. The slopes of our asymptotes, I always think of it as plus or minus delta y over delta x. Now, what is delta y? Delta y is whatever is under the y, just take the square root of that. So that would be the square root of 49 or 7. So if it's under the y, it's going to give us our delta y. If it's under the x, that's going to give us our delta x. So that's going to be the square root of 32. Now, if it's not a perfect square, 32 is not a perfect square, just give me that square root to the nearest tenth. So just take it out to the nearest tenth, because that's, you can't be much more accurate than that on a graph. So this is approximately 5.7. Now, steps 4 and steps 5, we are going to do kind of simultaneously. These kind of go together. We're going to graph the thing so we can find the vertices. We're going to graph it so we can find the vertices. So we're going to do 5 steps for every single one of these equations. So here's how we go about graphing it, which will then lead us to the vertices, which will answer the last 2 parts of our question. So let's get our graph paper ready. The first thing you do, just like a circle or an ellipse, put on the center. Okay, so our center is at 0, 0. I'm going to label it as such. I'm going to put a little C there. Next thing we're going to do is we are going to use our slopes to graph a line. If we know what point it goes through, if we have the slope, you just start at that point, go up and over, you got your line. So our slope is 7 over 5.7. So what I want you to do is go from that point, go up 7 over 5.7, up 7 to the left 5.7. So we're going to do it twice. Okay. So I'm going to go up 7 to the left 5.7. And just guesstimate the best you can. I'm going to go up 7 to the left 5.7. To the best of my ability, okay? Those two make our asymptotes. We're going to connect those 2 points with our center, and we are going to make them dashed lines. We're going to make a big old X, okay? So do your best to hit both of those points. Okay. Now we're going to find the vertices. So the graphing and the vertices go hand in hand. What direction did we say we were going? Up and down or left and right? The y came first. So are we going to go up and down or left and right? We're going to go up and down like a y value. Y values go up and down. The y came first, so we're going to go up and down. What number was underneath our y? The 49, right? So we're going to have to go plus or minus 7 in the y direction. So our vertices, just from center, go up 7, down 7. Go up 7, go down 7. Those are the points 0, -7, and 0, +7. You can even use that plus or minus notation if you have the urge. Now, those points tell us where our hyperbola pieces sit, but they're just like almost like giant wide parabolas. So just make they follow the asymptotes. So please follow the asymptotes. So that is our first example where we have done those 5 steps. So we're going to do those 5 steps every single time. I would just watch and I can send you the link to the video if you want. So that's our first example. Are there any questions about that one? Okay, now we need to skip down 2 pages, I believe, to where it says example 4. And could you please cross out the equation that's there and write down the equation that I have listed there. because I had not done any that open left and right. And so I wanted to have kind of one of each. So drop down to example 4, which is about 2 pages down, and write in that equation for me. X squared over 36 minus y squared over 64 equals 1. Now we are going to do the same 5 steps as before. The first step we have to ask is, where does it open? Well, if our x squared comes first and it is our positive value, it is opening in the x direction. So we're going to say that it opens left and right. So that's the first thing you always identify. How does it open? And this particular one opens left and right because the x's came first. The x's are my positive. Second thing we're going to find is the center. That's all about what have we added to or subtracted from our x and y. There's nothing there. We've subtracted and added nothing. Remember, that's always telling us it's at 0, 0. We'll do one that has an actual different center in a second. Third step we want to find is the slope of our asymptotes, which are plus or minus delta y over delta x. Always delta y over delta x. We find the delta y by whatever's underneath our y value. So we're going to use 64. So it's all about, am I under the y? That's where I get my delta y. So that is going to be plus or minus the square root of 64. The delta x is all about what's underneath our x value. So in this case, under our x value is a 36. So that's going to be the square root of 36. Now, what's great about those is they are nice, perfect squares. So that would be plus or minus 8 over 6. Now, you're welcome to reduce them, but 8 over 6 is helpful when we go to find the vertices anyway. So I don't usually go about reducing them. A slope of 8 over 6 is the same as 4 over 3, but in this case, it doesn't help us much. Let's just leave it 8 over 6. And that leads us to step 4 and 5, which is to graph it and find the vertices. I don't think that's how you spell that word. Maybe that's it. Okay. So let's go about going and doing steps 4 and 5. So we're going to set up our graph paper. We're going to label our center, in this case 0, 0. We're going to do rise over run to find our lines. We're going to go up 8 to the right 6. So I just went up 8 and over 6. And then go up 8 and to the left 6. Okay. And now you're going to graph your asymptotes. Okay. Now comes our vertices. We said it's opening left and right. So we're going to start here. We're going to count left and right. The same thing we did left and right before, 6. It's under our x, whatever comes first. So we're going to count 6 to the right and 6 to the left. It should line up with the points that we had, as long as you don't reduce, and it does line up. Label those with a V. Now we're just going to make that little giant wide U, or in this case it'll look kind of like a C, that follows our asymptotes. So follow the asymptote, follow the asymptote, follow the asymptote, don't touch, don't cross it, follow the asymptote. So it's sandwiched on either side of the x's. Now, let's figure out what our vertices were. So remember, we had to add our delta x, our plus or minus 6, onto our center. That's why we got 6, 0, and negative 6, 0 as our vertices. So that's how we graph a hyperbola, whether it's opening up or down, or whether it's opening left or right. Now, hyperbolas aren't functions. That's why we didn't do them earlier in the year. They are not a type of function, so they don't fall under the sum of the things we were doing with function notation. So that's why you kind of leave them in this conic section. Circles aren't functions. Ellipses aren't functions. These aren't functions of either x or y. They're kind of dependent on your x and your y. Now, let's scooch backwards a little bit to when we have a center at something other than 0, 0, in this case at HK. So the only thing you need to write down are those two equations. Remember, if the x comes first, we're opening left and right. If the y comes first, we're opening up and down. We're going to do the same 5 steps for these ones that we did for the other ones. Let's see if I can. We will be doing the same exact 5 things for these as we did for the other ones. So if it's x squared plus y squared equals a number, that's a circle. X squared over a number plus y squared over a number equals 1 is an ellipse. X squared over a number minus y squared over a number equals 1, or vice versa, is a hyperbola. So there are, so far we have 3 types that we have talked about through conic sections. And you need to be able to identify what those types are. We are going to be having a quiz on Friday. We will discuss the quiz more in depth, probably tomorrow. Okie dokie, now let's jump down to example 5A for me, please. Example 5A is what you see here. Go ahead and find that, and then you'll be ready to start looking at your homework. Okay, so there are 5 steps we're going to do. The first one is, how does it open? Well, if the y comes first, because the y comes first, that tells us that we are opening up and down. The second thing we have to find is our center, which is HK. Now, how do we find the H? Well, the H is going to be found with whatever is with our X. So remember, the H is going with the X. So the H, we're just going to do, where does X plus 1 equal 0? Well, that happens at negative 1. See how it becomes the opposite of what it was? What is our K? Well, that's what's inside of our Y value. So that's going to be, where does Y minus 2 equal 0? So that's going to be at 2. So our center, or our HK, is negative 1, 2. So if it's with the X, that's going to give you the X value of your center. If it's with the Y, it's going to give you the Y value of the center. It's not which comes first, it's where is it sitting? Is it sitting by the X? Is it sitting by the Y? Now let's find the slope. Remember, that's delta Y over delta X. Okay. Our change in Y is based upon what's under the Y. There's a 9 under the Y, so that's going to be the square root of 9. You can just do the square root of 9. I'm just showing you where it came from. The delta X is because of what's underneath the X. There's a 25 there, so that's the square root of 25. Or our slope is plus or minus 3/5. Remember, if those aren't perfect squares, just put it into a calculator. Tell me the nearest tenth. And now we're ready to do 4 and 5. remember we're going to graph it, which will give us the vertices. So let's get our graph paper all ready. This time we have a center not at 0, 0, but at -1, 2. Now, from that center, we use our slope. We're going to go up 3 over 5. And up 3 the other way 5. Okay, so count up 3 over 5. Up 3 to the left 5. Because one will be a positive slope to make the x, and one will be the negative slope, which will finish off our x. Make your x. Now, where do our vertices go? Well, the y comes first. So we have to use that delta y we found earlier. That was plus or minus 3 in the y direction. Now, our center was -1, 2, but we're going to be changing the y value by 3. So this changes by going up 3 and down 3. So our y value will change by 3. It'll go up 3. Our y value will go down 3. And you will see that's exactly where we land. Make those our v's. And now let's make our big, giant kind of U stuff. Okay. Our very, very, very wide parabola thing. Okay. And that's how we graph one that isn't centered at 0, 0 like before, but it still follows pretty much the same model as you see there. And do it by yourself, but you can always check it in Desmos. You're not going to be able to use Desmos on the quiz, but it's a good way to check your work as you go. And then that leads us to the homework. Problems 1 through 4, I only need these 4 things. I don't really need the graph for those 4. How does it open? What's the center? What are the slopes of the asymptote? What's the vertices? But I do need from 7 down, I need all 5 steps done. So follow my instructions, please. You can do all 5 steps for all of them, but I don't necessarily need the graphs for 1 through 4. If the graphs help you, do the graphs, because then you can find the vertices right there by counting. Okay. So you have to find the opening, the center, the slopes, the graph, and the vertices. Okay? Sound good? Wonderful and great. So you have the rest of the class period to work on these. Yeah.